Hello class. This particular standard is on INTEGRALS.5, and it's what it means is that you can understand and apply the first fundamental theorem of calculus. So let me saying, it's a big fancy term. What am I talking about? Really, what it means is that if f of x is some antiderivative of f of x, and f of x is continuous, then again, this is the first fundamental theorem of calculus, and you should have seen this last year. From some number a to some number b, the antiderivative of f of x is equal to the antiderivative of b, or antiderivative of f at b minus the antiderivative of f at a. So essentially what I'm doing is I take the antiderivative, I plug in b, I take the antiderivative and plug in a, and subtract the two values. So here we're saying, what is the definite integral, and how does it relate to area under the curve? Well, if you remember, if I said, hey, take the derivative at this point right here, what I was saying is find the slope. Or if you remember I said in the past, hey, what's the derivative at this point? Really what I'm saying is, what's the slope at that point? For antiderivative, when I say what's the antiderivative, it doesn't mean slope. What it means is the area under the curve. So this particular problem, it says determine the area between the curve and the x-axis on the given interval. So from for the function 9 minus x squared, from negative 3 to 3, find the area between the curve. What does that mean? It looks like, in this particular picture, I'll shade it for you. I'm trying to find out what is the area of that space. I could find the area of a rectangle, I could find the area of a circle, I could find the area of a triangle, but how do I find the area of, this weirdly shaped piece above the x-axis? Well, it's from a special way called the antiderivative. So what I'm going to do, as you saw in the first fundamental theorem of calculus, I'm going to write an antiderivative. I'm trying to find the area between negative 3 and 3. So my antiderivative, I'm going to draw a tiny negative 3 to 3. The function of this problem is 9 minus x squared and dx. Now, sorry, it's supposed to be dx. So now, how do I solve that? Again, what I'm going to do is I'm going to take the antiderivative, I'll plug in 3, I'll plug in negative 3, and subtract the two values. So first of all, the antiderivative, and this is how you write this out, this is, antiderivative of 9 is 9x, and the derivative of x squared is 1/3 x to the third. Then I draw these brackets, and then I write my bounds. So negative 3 to 3. So again, what I'm going to do is I'm going to plug in 3 into here, and get a number. I'll plug negative 3 in here, get a number, and subtract the 2. So first of all, let's try plugging in 3. And I'll do this in brackets. 9, 3, minus 1/3, 3 to the third power. So that's what happens when I plug in 3. Then I'll do the same thing, but subtract if I plug in negative 3. Then it's simply algebra. And again, some people get confused. In this step right here to this step, once I take the antiderivative, and I see this in some of your work, this integral sign and this dx disappear because I already took the antiderivative. So in this piece, I'm going to have 27 minus 9 minus negative 27. Negative 3 is negative 27 plus 9. So I'm doing the algebra. Then this equals 18 minus, and over here I'm going to have a minus 18. Okay, so far? So I'm just doing the algebra, and that equals 18 minus a minus 18 is 36. So what I just found was this space right here, like how big this area is 36 units. So that's the power of the antiderivative. There's another one here that we could do an example of, this negative square roots one, and trying to find the area. But I'll save that for another time. We're just going to move on. Hopefully you guys understand the process. Now, without a picture, and let's just say evaluate the definite integral in general, we're going to do the exact same thing. So here you see 1 to 8 of 4 of the cube root of x minus 2. So first of all, I can't take the antiderivative of that, so I'm going to convert it like so. You may notice also that in this particular problem, this 4 and this 2, they have a common factor, which is 2. So before it even starts, I'm going to take that 2 and pull it out in front of the integral. So that'll make, when I do the antiderivative, so much easier. So now what I'll do is I'll take the antiderivative. This 2 stays out in front. I'll do a bracket. I'll add 1, which is x to the 4/3, and I'll divide by it, which is the same thing as multiplying by 3/4. 2 times 3/4 is 3/2. And the antiderivative of 1 is just x. Now I'm running out of space, so I'm going to move over to the side for a second. But now all I do is plug in 8, plug in 1, and find out what the values I get and subtract the 2. So 2, 3/2, 8 to the 4/3, minus 8. Subtracting, the same thing, but with 1 in front of it, minus I'm running out of space here, so this looks weird. I apologize. And now all I do is do the algebra and get a number. So just for sake of time, again, you can plug this into a calculator and get the answer. One thing that looks a little bit confusing here, remember this 2 is in front of everything. So once I figure out, what I should do is another bracket here and here. Once I find my answer, I'll multiply it by 2. So if you remember in the original problem, I had 2 out in front of this integral. So whatever I get the answer of, I better multiply that by 2 because I factored it out at the beginning. Now, onto some easier things. Here are some properties of the definite integral. If you have, integral from b to a, it means the exact same thing if the bounds were flipped, but it's the negative version of it. So the antiderivative of 1 to 2 is the same thing as the negative version of 2 to 1. If you have the possibility of the bounds are the same, like from 2 to 2 or 3 to 3, no matter whatever that number is, it's always the area between the same, the area between 2 points that's exactly the same is always 0. And then you may have heard of like the transitive property, but if the integral from a to b, if I don't have that exact value, but I do have the value from a to c and c to b, like the go-between, I can add these two values up and it'll give me the same value of a to b. So we'll look at some of these examples. So they're giving us, in this example, the answers for certain antiderivatives. From -2 to 3, it's 11. From 4 to 3 is 5. And from 3 to 9 is 7. So we're expected to use this information to solve these problems. And the problem is that, not there's a problem, but the thing is that there is no function. They didn't give us some antiderivative. They just gave us these values. So first of all, it says, what is the antiderivative between 3 and -2? Well, I don't have any 3 to -2, but I do have -2 to 3. So see how these two right here are exactly the same but flipped? So by the properties of the definite integral, if -2 to 3 is 11, that means 3 to -2, the bounds flipped, is equal to -11. This one on the right, -2 to 3, I already have -2 to 3. So the only difference is that this one has a 3. So what I'll do in this problem is I will factor out the 3. Like so. This piece right here, and I'll even highlight it for you. This piece right here, we found, or it's given to us as 11. So 3 times 11 is 33. This next one is -2 to 4, and I don't have -2 to 4. But you may notice I have -2 to 3, and I have 4 to 3. So in this particular problem, this means the exact same thing as -2 to 3 plus 3 to 4. Right? Again, I don't have -2 to 4, but I do have -2 to 3, and I do have 3 to 4. So instead of going straight from -2 to 4, I have essentially like a go-between to get that answer. -2 to 3, we already said before, is 11. So that part becomes easy. We don't have technically 3 to 4, but we have 4 to 3. So instead of writing 5, I'm going to write -5. So my answer is going to be 6. This problem, they want to know what from 7 to 7 is. And again, at every time that you have the bounds are exactly the same, the answer is always going to be 0. And the last type of problem you should know, and then here's some more other ones. I guess we could do these. This one says 4 to 9 right here. And if I look up here, I don't have 4 to 9, but I do have 4 to 3 and 3 to 9. So if I add these two up, like to get 4 to 9, 5 plus 7, that one's going to be 12. This one says I want 9 to negative 2. I don't have 9 to negative 2, but I do have 9 to 3 and 3 to negative 2. So this means the exact same thing as, 9 to negative 2 means the exact same thing as 9 to 3 plus 3 to negative 2. 9 to 3 is, we don't have 9 to 3, we only have 3 to 9, so it's going to be negative 7. And this one, this 3 to negative 2, we also don't have, it's going to be a minus 11. So my answer is going to be negative 18. And this last one, negative 2 to 4 of f of x plus 3, well, what I'm going to do is split this up into two separate problems. This one's going to be negative 2 to 4 of f of x plus, actually, so I'm going to split this up into two problems. I'm going to take this integral and apply it to this one and this one. Can't forget my dx's. This first one, negative 2 to 4, again, if I look at what's given to me, negative 2 to 4, we already did here in this problem, and we got the answer to be 6. And if you forgot how to do it, you could see it like in your notes. So I'll make this 6. Now some of you may be wondering, what do I do with this negative 2 to 4 of 3? You know, like what do I do with that? Well, this is just a simple antiderivative problem. The antiderivative of 3 is 3x. So I'll write it like so, like what we did in the beginning of the notes. And then I'm going to plug in 4, plug in negative 2, and subtract the answers. So 6 plus, if I plug in 4, I get 12. And if I plug in 2, I get negative 2, I get negative 6. So what I did was plug in 4, plug in negative 2, and get the numbers. If I add these two, I get 18, and the answer is going to be 24. Alright, the last section is about a graph again, but they don't give you any numbers. They want you to know, or want you to find out, what is the area under these curves based on these shapes. So I'll just do a couple of them. This one says negative 2 to 2. So you notice from negative 2 to 2, this shape looks like a half circle. So if you don't see it, I could highlight it for you. It's this piece right here. I'm trying to find that area. So this is a circle, half a circle, and you should know the area of a circle is pi r squared. And it's half of a circle, so this area is going to be half pi r squared. Now the radius of this circle is a radius of 2. So all I'm going to do is plug in 2, which gives me 4. Which gives me an answer of 2 pi. So the antiderivative between negative 2 and 2 of this function is 2 pi. This one says negative 6 to 7 for gx. And again, this function is g. First thing I'm going to do is I'm going to take out the 4 and leave it like so. Now, I need the antiderivative between negative 6 and 7. Again, there's no function here, so I have to find out the actual areas. So I'm trying to go from negative 6 to 7. So it's the area of this plus what I already found, and I'll even label it, plus the area of this. And I'll put a dotted line so you know where I stopped. You may notice that this one is below the x-axis, so this is actually going to be a negative number. This one you notice is a triangle. So the area of a triangle is half base times height. Here I have a base of 4, and I have a height of 3. So 4 times 3 is 12, half of 12 is 6. So this area is 6. This one right here is a trapezoid, and some of you may have forgotten what's the area of a trapezoid. So to make it even easier for you, what if I make this into a triangle and a rectangle? Okay. This area is 2 times -4, so this has an area of -8. This one is a triangle again. I have a base of 3, and I have a height of -4. So half base times height, 3 times -4 is -12. Right? 1, 2, 3, 3 times 4, -4, -12, and half of that is -6. So to find this answer, what I'm going to do is I'm going to add up all these numbers. 6 plus 2 pi plus -6 plus -8. You may notice that these cancel, so the answer is 2 pi minus 8. So this whole thing just turned into 2 pi minus 8. Remember I factored out a 4, so my final answer is going to be 8 pi minus 32. So I think you sort of get the basics. There's no real tricky parts to this. The one confusing one you may see is if the numbers are flipped. Do you see how these ones go from smallest to largest, smallest to largest, smallest to largest? So some of you may say, like, what do I do if I have a 9 to -9? Remember, that means the exact same thing as the negative version of the bounds flipped. So other than that, I think you should be able to solve the rest of them. For the rest of class, what I want you to do is to do the problem sets, and you'll turn it in at the end of class. So, I mean, I'm only missing you guys for one class, so I hope you enjoy your 4-day weekend, and I'll see you all next Tuesday. Take care.